is a demonstration on how to solve using Excel a problem, and I selected the one that is shown in your textbook. I'm sorry, in the slides. Maximization, as you can see in the box, in the word box that I inserted, maximize 5x1 plus 7x2 subject to x1 less equal to 6 and 2x1 plus 3x2 less equal to 19 and x1 plus x2 less equal to 8, and the non-negativity constraint x1 and x2 must be greater or equal to 0. Now the instructions in Excel are also shown on pages 298 through 301. You can review that if you want to. Now what is the problem that I have here? I'm going to type here just the coefficients. The objective function is to maximize 5 times x1 plus 7 times x2. Okay? And subject to constraint 1 is just 1 times x1 plus 0 times x2. That's constraint number 1. And as the right hand side we have 6 here, so I just type 6. Constraint number 2 is, I'm just following, remember that it's 2x1 plus 3x2 less equal to 19. That's the second constraint. So I'm just type 2 and 3 and 19. And finally constraint number 3 and 1x1 plus 1x2 and less equal to 8. So all that I'm doing is typing the coefficients. Now the decision variables are x1 and x2. If you want, you can do whatever suits you better, or whatever style you would like to do, but I just type x1 and x2 again, but you could have just left this empty, and the decision variables are going to be shown in these two cells. That's where my optimal solution is going to be reflected once I solve this problem using Excel. Now the next is the instructions for Excel. Excel formulas. What is the objective of this problem? Is to maximize this particular cell. What is that particular cell? Now I'm going to put the formula. The formula is B5, which is, no, that's B4. B4, which is 5 times x1, which is my decision variable x1, and that is on cell B10, plus 7x2, which is cell C4, times C10. That's my objective function. Now subject to constraint 1, and I'm going to put equal now. Constraint 2, let me put the 3 constraints. And the constraints are going to have a left hand side and a right hand side, and a possible slack or surplus. What is my left hand side for constraint number 1? I'm going to type the formula that describes constraint number 1. All I need to do is multiply the coefficient of x1 times x1 plus the coefficient of x2 times x2 on the left hand side, the same way you see it written on the problem in the box. x1 less equal to 6. Okay, but I'm not going to write less equal to 6 here. I'm just going to write what I have on the left hand side, which is x1. Well, what it is 1, my first constraint, my first variable coefficient times x1 plus 0 times x2, and as you can see, this is B6 is my first constraint times x1, but x1 is my variable x1 that is selected here on that cell B10 plus the second coefficient is C6 times C10. Okay. Now, as you can see, I'm going to have to, if I hit enter, I'm going to get 0 here right now because I don't have specifications for these values. And however, I'm going to have to copy the cell to the other two so that I can apply the formula for the other two constraints. So what I need to do is just fix this cell B10 and the cell C10 by putting a $sign in between the letter, hit enter, you get the same result. But now I can just copy it to the other two cells, one extra here. And if you notice on this one, as you can see on the screen above, here B7 times B10 plus C7 times C10, and then the next one is B8 times B10 plus C8 times C10, and the B10 and C10 are repeated because I fixed them. Now what are the right hand sides? The right hand sides are D is equal to D6, which is 6, and I'm just going to copy to the next two so that it can go down to the 19 and the 8. And my slack and surplus is defined, as you can verify that from your reading, is the right hand side, which is C15 in this case, minus B15. Right hand side minus left hand side. Click enter, and at this point is 6, and then copy to the other two cells. Now we're ready to solve the problem since we have already entered the relevant formulas. To solve the problem, you need to go to data, which is already we are already on the data tab, and here you go, remember data analysis, right under it you need to have solver here, and in case you don't have solver, you have to go to file here and click on add-ins or options and then add-ins. Let me show you add-ins, and then analysis toolpack. Same way you install data analysis, and then here you check the box for solver. Alright, so now we have solver, and since we already have it on my Excel, then you just click on solver, and let me reset all here to start a new problem. And what do I have here? Well, notice set objective, it says here. Well, what is my objective? By default is selected as maximization. And indeed, well, that's what we have in this problem. So I need to maximize my objective function, which is this one here, this cell B13. That is my objective function. And remember to click on the formula on the cell that you have the formula for the objective function, or 5x1 plus 7x2 in this case, by changing variable cells. What are the variables changing here? Well, the two decision variables. They are the ones that are changing. And here I'm going to see the answer after I apply solver. Now click inside here, the subject to constraints, and add your constraints. Now I'm going to do one by one. I'm going to click on the red arrow and select left hand side for the first constraint. And then notice by default is less equal to here, but you can select equal or greater equal, but I'm going to keep the less equal because that is the sign that we need to use in this problem. And then click inside here to indicate right hand side. Click back, see, click OK, and now you have the first constraint. Now you add a second constraint, which is the left hand side minus right hand side. Notice I'm also just clicking on the cell itself, and that way you can add the same thing, the same constraint. And finally add the third constraint, let's equal to right hand side 8. Okay. Now, something you could have done is to simply add one time since all these constraints have the same inequality sign, less equal to, then you could have selected all of the left-hand side cells, in this case B15, B16, and B17, all at once, less equal to than the right-hand sides, which are C15, C16, and C17, which will have been exactly the same thing. Now, make sure that this box is checked to obtain non-negative values, and make sure that the method here selected is simplex LP. By default, Excel is going to take you to GRG nonlinear, but you need to check it, to change it to simplex LP. And now just click on solve. And notice the answers are already shown here, and click OK here. Keep solve resolution. And notice the answer is x1 is 5, x2 is 3, and the objective function value is 46. So this is the method that is used to solve linear programming problems. And so you can use the same thing, the same approach to solve any problem: maximization, minimization,